Good day. Welcome to Session 8, Telecommunication 1. Introduction. Telecommunication is a very important aspect of the information system as it involves how a firm communicates over the network and how information is sent and received. This study session will present a background of telecommunication covering network technologies, transmission media, internet technology, radio frequency, and wireless sensors. You will learn how telecommunication evolved, discuss computer networks and telecommunication media, and finally the physical transmission media. When you have studied this session, you should be able to highlight the principal components of telecommunications networks, discuss evolution of telecommunications, explain telecommunications transmission media and types of networks, describe the physical transmission media. Evolution of telecommunications. Two fundamentally different types of networks were used in the past: telephone networks and computer networks. Telephone networks historically handled voice communication, and computer networks handle data traffic. Telephone networks were built by telephone companies throughout the 20th century using voice transmission technologies, hardware and software. And these companies almost always operated as regulated monopolies throughout the world. Computer networks were originally built by computer companies seeking to transmit data between computers in different locations. Telecommunications providers today, such as AT&T and Verizon, offer data transmission, internet access, cellular telephone service, and television programming, as well as voice service. Cable companies such as Cablevision and Comcast now offer voice service and internet access. Computer networks have expanded to include internet telephone and limited video services. Increasingly, all of these voice, video, and data communications are based on internet technology. Both voice and data communication networks have also become more powerful, faster, more portable, smaller and mobile, and less expensive. Internet users have high-speed broadband connections provided by telephone and cable TV companies running at 1 to 15 million bits per second. Computer networks. A network consists of two or more connected computers, a client computer and a dedicated server computer. Network interfaces. A connection medium, network operating system software, and either a hub or a switch. Each computer on the network contains a network interface device called a network interface card, NIC. Most personal computers today have this card built into the motherboard. The connection medium for linking network components can be a telephone wire, coaxial cable, or radio signal in the case of cell phone and wireless local area networks, Wi-Fi networks. The network operating system, NOS, routes and manages communications on the network and coordinates network resources. It can reside on every computer in the network, or it can reside primarily on a dedicated server computer for all the applications on the network. A server computer is a computer on a network that performs important network functions for client computers, such as serving up web pages, storing data, and storing the network operating system, and hence controlling the network. Server software such as Microsoft Windows, Server, Linux, and Novel Open Enterprise Server are the most widely used network operating systems. Most networks also contain a switch or a hub acting as a connection point between the computers. Hubs are very simple devices that connect network components, sending a packet of data to all other connected devices. A switch has more intelligence than a hub and can filter and forward data to a specified destination on the network. A router is a communications processor used to route packets of data through different networks, ensuring that the data sent gets to the correct address. Networks in large companies. The network we've just described might be suitable for a small business, but what about large companies with many different locations and thousands of employees? As a firm grows and collects hundreds of small local area networks, these networks can be tied together into a corporate-wide networking infrastructure. The network infrastructure for a large corporation consists of a large number of these small local area networks linked to other local area networks and to firm-wide corporate networks. A number of powerful servers support a corporate website, a corporate intranet, and perhaps an extranet. Some of these servers link to other large computers supporting back-end systems. Today's corporate network infrastructure is a collection of many different networks, from the public suite telephone network to the internet to corporate local area networks linking work groups, departments, or office floors. One of the major problems facing corporations today is how to integrate all the different communication networks and channels into a coherent system that enables information to flow from one part of the corporation to another and from one system to another. As more and more communication networks become digital and based on internet technologies, it will become easier to integrate them. Two key digital networking technologies. Contemporary digital networks and the internet are based on three key technologies: client, server, computing. The use of packet switching and the development of widely used communication standards, the most important of which is Transmission Control Protocol and Internet Protocol, or TCP and IP, for linking disparate network and computers. Client and server computing. This is a distributed computing model in which some of the processing power is located within small, inexpensive client computers and resides literally on desktops, laptops, or in handheld devices. These powerful clients are linked to one another through a network that is controlled by a network server computer. The server sets the rules of communication for the network and provides every client with an address so others can find it on the network. Client-server computing has largely replaced centralized mainframe computing, in which nearly all of the processing takes place on a centralized mainframe computer. Client and server computing has extended computing to departments, work groups, factory floors, and other parts of the business that could not be served by centralized architecture. The Internet is the largest implementation of client and server computing. Packet switching. This is a method of slicing digital messages into parcels called packets, sending the packets along different communication paths as they become available, and the reassembling the packets once they arrive at their destinations. Prior to the development of packet switching, computer networks used leased, dedicated telephone circuits to communicate with other computers in remote locations. In circuit switch networks, such as the telephone system, a complete point-to-point circuit is assembled and then communication can proceed. The packets include information for directing the packet to the right address and for checking transmission errors along with the data. The packets are transmitted over various communications channels using routers, each packet traveling independently. The packets are transmitted over various communications channels using routers, each packet traveling independently. Packets of data originating at one source will be routed through many different paths and networks before being reassembled into the original message when they reach their destinations. TCP and IP and connectivity. In a typical telecommunications network, diverse hardware and software components need to work together to transmit information. A protocol is a set of rules and procedures governing transmission of information between 2 points in a network. In the past, many diverse proprietary and incompatible protocols often forced business firms to purchase computing and communications equipment from a single vendor. But today, corporate networks are increasingly using a single common worldwide standard called Transmission Control Protocol and Internet Protocol, TCP and IP. TCP and IP uses a suite of protocols, the main ones being TCP and IP. TCP refers to the Transmission Control Protocol, TCP, which handles the movement of data between computers. TCP establishes a connection between the computers, sequences the transfer of packets, and acknowledges the packets sent. IP refers to the Internet Protocol, IP, which is responsible for the delivery of packets and includes the assembling and reassembling of packets during transmission. There are 4 layers of the TCP and IP suite, which will be described. Application layer. The application layer enables client application programs to access the other layers and defines the protocols that applications use to exchange data. One of these application protocols is the Hypertext Transfer Protocol, HTTP, which is used to transfer web page files. Transport layer. The transport layer is responsible for providing the application layer with communication and packet services. This layer includes TCP and other protocols. Internet layer. The Internet layer is responsible for addressing, routing, and packaging data packets called IP datagrams. The Internet Protocol is one of the protocols used in this layer. Data are grouped into small packets which are transmitted independently over various communications channels and reassembled at their final destination. Telecommunication media. Signals, digital versus analog. There are 2 ways to communicate a message in a network, either using an analog signal or a digital signal. An analog signal is represented by a continuous waveform that passes through a communications medium and has been used for voice communication. The most common analog devices are the telephone handset, the speaker on your computer or your iPod earphone, all of which create analog wave forms that your ear can hear. A digital signal is a discrete, binary waveform rather than a continuous waveform. Digital signals communicate information as strings of two discrete states, 1 bit and 0 bits, which are represented as on-off electrical pulses. Computers use digital signals and require a modem to convert these digital signals into analog signals that can be sent over or received from telephone lines, cable lines, or wireless media that use analog signals. Modem stands for modulator, demodulator. Cable modems connect your computer to the internet using a cable network. DSL modems connect your computer to the internet using a telephone company's landline network. Wireless modems perform the same function as traditional modems, connecting your computer to a wireless network that could be a cell phone network or a Wi-Fi network. Without modems, computers could not communicate with one another using analog networks, which include the telephone system and cable networks. Types of networks. There are many different kinds of networks and ways of classifying them. Local area networks. If you work in a business that uses networking, you are probably connecting to other employees and groups via a local area network. A local area network, LAN, is designed to connect personal computers and other digital devices within a half-mile or 500-meter radius. LANs typically connect a few computers in a small office, all the computers in one building, or all the computers in several buildings in close proximity. The router connects the LAN to other networks, which could be the internet or another corporate network, so that the LAN can exchange information with networks external to it. The most common LAN operating systems are Windows, Linux, and Novell. Each of these network operating systems supports TCP and IP as their default networking protocol. Three functions of the modem. A modem is a device that translates digital signals into analog form and vice versa, so that computers can transmit data over analog networks such as telephone and cable networks. Ethernet is the dominant LAN standard at the physical network level, specifying the physical medium to carry signals between computers, access control rules, and a standardized set of bits used to carry data over the system. Originally, Ethernet supported a data transfer rate of 10 megabytes per second, Mbps. Metropolitan and wide area networks. Wide area networks, WANs, span about geographical distances, entire regions, states, continents, or the entire globe. The most universal and powerful one is the Internet. Computers connect to a WAN through public networks, such as the telephone system or private cable systems, or through leased lines or satellites. A metropolitan area network, MAN, is a network that spans a metropolitan area, usually a city and its major suburbs. Its geographic scope falls between a WAN and a LAN. Physical transmission media. Networks use different kinds of physical transmission media, including twisted wire, coaxial cable, fiber optics, and media for wireless transmission. Each has advantages and limitations. A wide range of speeds is possible for any given medium depending on the software and hardware configuration. Twisted wire consists of strands of copper wire twisted in pairs and is an older type of transmission medium. Many of the telephone systems in buildings have twisted wires installed for analog communication, but they can be used for digital communication as well. Although an older physical transmission medium, the twisted wires used in today's land, such as cars, can obtain speeds up to 1 gigabyte per second. Twisted pair cabling is limited to a maximum recommended run of 100 meters, 328 feet. Coaxial cable, similar to that used for cable television, consists of thickly insulated copper wire that can transmit a larger volume of data than twisted wire. Cable was used in early lands and is still used today for longer, more than 100 meters, runs in large buildings. Coaxial has speeds up to 1 gigabyte per second. Fiber optic cable consists of bound strands of clear glass fiber, each of the thickness of a human hair. Data are transformed into pulses of light, which are sent through the fiber optic cable by a laser device at rates varying from 500 kilobytes to several trillion bits per second in experimental settings. Fiber optic cable is considerably faster, lighter, and more durable than wire media, and is well suited to systems requiring transfers of large volumes of data. Communications transmitted from a cell phone to a local cell pass from antenna to antenna, cell to cell, until they reach their final destination. Wireless networks are supplanting traditional wired networks for many applications and creating new applications, services, and business models. Study session summary. In this study session, we discuss the principal components of telecommunications networks and key networking technologies, the main telecommunications transmission media and types of networks. We also analyzed how telecommunication evolved. End of study session 8. Thank you for listening.